Our next exercise we're going to look at is 6D, which is seasonal indices. Now, I'm not going to have too many scribbles on this one. I'm just going to talk you through it. So, when the data is seasonal, it is often necessary to deseasonalize the data before further analysis. So that's just another word for saying we're going to smooth the data out like we did in the previous few exercises. To do this, we need to calculate seasonal indices. So consider the hypothetical monthly seasonal indices for unemployment given in the table. So let's have a look at these numbers. They're all around the 1 mark, aren't they? Sometimes you might see them around the 2. But the one big thing I want you to find out is this total here, because this comes up in seasonal indices questions all the time in exams. If there are 12 months in the year, it's going to equal up to 12. It has to. If there's 7 days, the total is going to be 7. If they do quarters, it's going to be 4. Okay, so the seasonal indices have to add up to how many seasons there are. In this case, there's 12 months. And that's what they go through in this first part here. The second key fact, seasonal indices tell us how a particular season, generally a day, month or quarter, compares to the average season. For example, seasonal index for unemployment for the month of February is 1.2. Up here, 1.2. Or 120%. Remember, we just go from decimal to percentages. This tells us that February unemployment figures tend to be 20% higher than the monthly average. If all months were the same, these will all be 1 to add up to 12. But in Feb, it's telling us it's 20% higher. The seasonal index for August is 0.9 or 90%, which means it's 10% lower than the monthly average. That second sentence I find is easy to remember. Think of 100%. If it's lower, you say how many percent it is lower. Now we can use seasonal indices to remove the seasonal component. That's when we deseasonalize it. That's when we flatten it out from a time series, or we can put it back in, which means we go back to the raw data where we reseasonalize it. So make it flat, deseasonalize, go back to the raw data, reseasonalize. Using seasonal indices to deseasonalize or reseasonalize a time series. So this rule is pretty straightforward. If we want to deseasonalize a raw figure, we use the actual figure and divide it by the seasonal index. Here's an example. The seasonal index for cold drink sales for summer is 1.33. If we remember before, that means it's 33% higher in the summer. Last summer, beach kiosks' actual cold drink sales totaled 15,653. What were the deseasonalized sales? So to deseasonalize it, remember we use the actual sale, which is that amount, and then we divide it by the seasonal index, which is this amount. So to make it deseasonalized, to make it more relevant for the whole year, we divide it by that larger number, which makes it 11,769.17 So that's how we deseasonalize. If we want to go the opposite way, I think you can pick, even before I show you, if I want to find the actual, I'm going to have to get rid of this seasonal index. I'm going to have to times it out, aren't I? So let's have a look what happens. So to reseasonalize the data, we then go to the deseasonalized figure times the seasonal index. So just the inverse from before. The seasonal index for cold drink sales for spring is 0.85, so it's 15% lower than the average. Last spring, a beach kiosk deseasonalized cold drink sales totaled 10,870. So what we do here, we then go that amount times the 0.85, which means the actual sales figures for that spring were 9,239.5. So you see how it's bringing those two values closer together, the 11,000 and the 9,000. That's what's happening with this deseasonalizing and reseasonalizing. So let's do a time series. The quarterly sales figures for Mickey's shop over a 3-year period are given. Alright, so let's have a look at this. Use the seasonal indices shown to deseasonalize these sales figures. Write answers correct to the nearest whole number. So what's going to go on here is this. All the summer values are going to be divided by the summer seasonal index. All the autumn values are going to be divided by the autumn seasonal index. And we get going through winter with winter, spring with spring. You'll notice here spring is a fairly low number, 0.52. If I divide any of these numbers by that, it's nearly going to double, isn't it? Because if I divide by half, it's nearly like timesing it by 2, which shows us those values. So what you'll see here, once we deseasonalise everything, all the numbers are pretty similar now. So we can get an overall trend of what this business is going to be like and how many figures we can sort of sell on average. Comparing a plot of the raw data with the deseasonalised data. So that's what we had before. The raw, and there is that smoothing of the data that we learnt from the last few exercises. Two things to be noticed that deseasonalising has removed the seasonality from the time series plot because we deseasonalised it and revealed a clear underlying trend in the data. It is common to deseasonalise time series data before you fit a trend line. You would see that in the COVID going on right now. Calculating seasonal indices. So how on earth do we do this? To complete this section, you will now learn to calculate a seasonal index. We will start by using only 1 year's data to illustrate the basic ideas and then move on to a more realistic example where several years' data are involved. So this is Mickey again. So what's going on here? To get a seasonal index, all right? So we're going to go these 4 seasons, add them up, divide by 4, gives us an average, all right? Gives us a beautiful average. Then each of these 4 numbers gets divided by that quarterly average, okay? Then gets divided by it. So what you'll see here, we've got all these new seasonal indices, all right? And if we add those 4 together, it adds up to 4.001, but it's 4. 4 for the 4 seasons. That's the answer. Then what happens if we have to use several years worth of data, and I want you to pay attention to this, we do the same thing for each and every single year. So we do add them up, all right? Or that's from year 1 from before. So to do year 2, we've got these 4 numbers. You'll notice down here, divide by 4 gives us a quarterly average. And then, like the previous example, we then use each of those values from summer, autumn, winter, and spring, those 4, and we divide by the quarterly average that we just found out. And then we end up with those 4 seasonal indexes for that second year. And we end up with the same thing for the third year. Same thing, add up those 4 numbers from well above. There's that quarterly average, divide by that number by that third year's values. And there are the season 3 seasonal indices, or year 3 I should say, sorry. So what we're going to do here now, all right, we're going to find the final seasonal indices. So we have to add up all 3 season indices. So for the summer, get the 3 summer values. That, and you'll see the last summer one is right there. Year 1, year 2, year 3. Divide by 3 because it's 3 years worth. There it is there. Seasonal index. And the same thing for autumn, winter, and spring. You'll see what we've got here for autumn, 1.119. There's that value there from year 3. That'll be year 2s, that'll be year 1s. And we get the 4 seasons, summer, autumn, winter, and spring. And once we've got the final seasonal indexes, adds up to 4. So this last part here just goes through what we've already spoken about, how to interpret, because it is a big intro into this exercise. And best of luck with it.